X-ray science has come a long way since X-rays were first discovered. Frau Röntgen's hand, 1895, was a good example of being able to see things that you could not normally see, understanding the structure of what was in her hand, see your bones without having to remove the flesh from it. As time has gone on, people have been able to look at things that are smaller and faster. We now routinely use X-ray diffraction to discover the structure of molecules. We are just barely starting to use X-ray diffraction to discover how molecules change. One of the goals of science is to be able to understand how molecules do their function over time by watching how they go through whatever transformation is involved. How does an enzyme grab onto some substrate, perform a chemical reaction, split that molecule in two, and spit out the products? We'd like to be able to see that structure step by step as it goes. That's something that we really can't do very well now, but it's something that people are dreaming about. We would like to be able to understand macroscopic changes at rapid timescales. When a crack happens and that crack grows, exactly what are the details at the growing point of the crack? So we'd like to be able to use X-rays to examine the structure of that crack right at that point at a time scale that's fast enough that we could really see how the atoms are rearranging as the crack progresses. If we could do that, perhaps we could figure out how to stop the cracks from happening in the first place. We'd like to understand realms of matter that are very prevalent in the universe, but very hard to do on Earth. If you look around the stars, you look at Jupiter, the interior of Jupiter, you find that matter is at extremely high temperatures and very, very dense. Warm and dense matter, as it's called, is prevalent all around the universe. What's the structure of warm, dense matter? Well, it turns out on Earth, we can make warm, dense matter. We can take something, for example, hit it with a laser beam, warm it up, but it explodes, okay? But if you want to understand what the structure of warm, dense matter is, you have to be able to examine that structure in the nanosecond or the few picoseconds before it explodes, okay? So if you could do that, then you could start to understand more details about the structure of what happens inside stars and what happens inside Jupiter. That's the future. It's a long ways from where we were, but it's where we're heading.
That's exciting.
Yeah, it is exciting.
Yeah.
That was great.
That's why it's fun to be a scientist.